When you use weight to control your production process, you want to see clean and clear weight signal because noises in the weight signal will reduce the control performance. Normally people use low-pass filter to reduce the noises. However, the low-pass filters are not optimal for low-frequency noises. Such low-frequency noises can come from different sources from the field, for example, a slowly turning motor, or just from the mechanical resonance. In this video, you will see how the IND360 Notch Filter helps you to filter out a noise at a specific low frequency. Now with this demo system, I have an IND360 connected to a bench scale. And on the bench scale, I have a 5 kilogram weight, a battery, and a motor. When the motor is not running, the weight is stable. And now I switch on the motor. Now the weight is not stable anymore. And in the IND360 web interface, under Scale, Filter and Stability, you will see the weight in the graphic format. The blue signal is the raw weight signal, and the peak-to-peak value is about 300 grams. And the orange signal is after the low-pass filter, and the peak-to-peak is about 30 grams. And now let's see how the IND360 Notch Filter works against this noise. But first of all, we have to know where is the noise frequency. In the web interface, you will see the spectrum of the noises. And here in our case, we will find the main frequency is at 3.28 Hertz. Now let's go up and put this frequency to the notch filter and enable it. You see here, once the notch filter is enabled, the weight is much more stable and it's only toggling at the last digit. Let's also check the dynamic performance. I will add and remove additional weight on the scale. And as you see, the weight change is immediately visible. That means the dynamic performance is good even with such a strong noise attenuation. This is how IND360 Notch Filter helps you to handle the low frequency noises in your system while maintaining a very good dynamic performance. Thanks for watching.